When preparing for operations at the LETF or preparing for the design, we go through a number of different aspects of that, right? And so there's the design analysis, which encompasses a number of different things. There's reliability analysis for each one of your different components. There's the design analysis, which says, are we meeting each of our requirements? And so there's a number of different design requirements, which is, are we meeting our factors of safety on each of the materials? Are we, and so that can be strength, that can be a number of different things. And are we also meeting our value requirements with regards to the vehicle? In addition, we also do things like, failure modes effect analysis, which we go through and we say, what are our different potential failure modes and what would be the consequences of each one of those things. In addition, we also, as we prepare for operations, which is probably more what we've been seeing at the LETF, which is as we prepare for something like a hazardous cryogenic operation, right? So we're getting ready to flow something like liquid hydrogen, which is a very flammable substance. We go through and we plan in great detail what are each of the individual things that could happen with this. Where can hydrogen store? Where can it, what are potential ignition sources? And we go through each one of those potential hazards and we do great detailed analysis. We eliminate every one of those potential ignition sources. We go through and anything that could be potentially class 1, div 2, and we go through the entire facility. What we found at the LETF is that took probably about 2 months to prepare that entire facility for a full hazardous operation, which was significantly longer than what we had originally expected. We had to modify fire suppression systems. We had to modify all the electrical outlets. We had to do all of these sorts of different things. And then we also had to prepare all emergency egress procedures, things like that, and had to train a lot of people who weren't really prepared for those because we lost a lot of people from shuttle that were very familiar with liquid hydrogen operations. And so that was something that we spent a lot of time on. What we did though is we made sure we took the appropriate time, because if we didn't, this was something that could cause a lot of damage both to hardware but more importantly to people. So for right now, where we're working on the GSE, which is the ground support equipment, it's a GSDO-owned risk. When we get into the flight processing, what we would do is that would then be, probably a problem report, and it would be a jointly kind of worked issue between us and the flight program. So we would, as we're processing that flight vehicle, we would take that PR or a problem report on the flight hardware because we're working on it here. But the disposition of that would be a jointly worked thing between us and the flight program. Depending on what the issue is, you would probably need the design entity to buy off on the resolution of it unless there's some sort of standardized fix for it. Some of the things that I think we found is our umbilical designers definitely did learn some things from our history. If you look at some of our hydraulic actuators, right, they're actually Apollo heritage design, or actually even before that, to be honest, but they were used Apollo, Shuttle, and now in SLS and Orion. I think if you look at some of our designs, we definitely have some that really leverage the best of all of our history. If you look at our forward skirt umbilical design, if you look at our core stage intertank umbilical design, these plates, these test campaigns, they came off and we got those done in, less than 4 months, less than 3 months, those sorts of things. And they worked really well because they really were very simple in their concepts and things along those lines. And we're going to leverage those kind of moving forward in the EUS. The ICPSU, which has been probably the most complicated of our umbilicals, was leveraging a lot of details off Delta 4. And so is very heritage in that. And it didn't, it's been very complicated to get all those mechanisms to work and the pull-offs and the timing and things along those lines. So what we really did find is simple is better, and to to try and get the number of mechanisms working together as minimal as possible. And so, you know, in some cases that's not possible. But ICPSU, which has been very, very complicated, the number of mechanisms that they have to have timed down and working together is many, many, many times that of some of the other umbilicals. So they, you know, they're minimizing that for moving forward to EOS. When you look at some of these designs for our umbilicals, they began in constellation and then matured through a number of years. I mean, in some cases, 10 years or so. And what we found is that over that time period, designers may have changed 1, 2, 3, sometimes in cases even more times. And now at the launch equipment test facility, right, this is the culmination of all this number of years of work, right? And while launch vehicles changed, while the spacecraft changed and during this time frame, some of and you know, these designs were updated many, many times. Some of the analysis didn't always follow right in suit, right in sync. And so this is the test facility where the rubber hits the road, where everything kind of comes together, and we find any gaps that were done and, you know, left in the design, any gaps that were left in the analysis, because everything has to perform. And so what we expected in the schedule in terms of nonconformances, what we expected in the schedule in terms of performance parameters, you know, what we should have expected is probably a little bit more growth, because this was a design done over 10 years with multiple changes, multiple designers and things like that. Because again, right, if this was a design done over 1 year or 2 years with a short fabrication time period, you would expect less anomalies in the design. But because this was done over such a long period of time, we have found additional anomalies, because again, when you have, you know, in some cases 5, 6 hydraulic designers or something like that, you have some other deficiencies in the design in certain cases that you wouldn't otherwise expect, because it was modified several times to suit different purposes and other things like that. And so just some unintended consequences.